Assalamualaikum class and welcome back. Alright, so for today we will continue with second order differential equation. Before that, let's see for the examples that we have learned before this. So we have first ODE. Okay, for the first ODE, the highest order for your derivative in your equation, it will be first order. So let's see here. If you write in the form of prime, it will be the highest order is y prime. For example, we have the first one y prime plus 2y plus 3 equals to 4x. Okay, so in first ODE, to solve the first ODE, basically you will write in the form of dy dx. Then when you rewrite in the form of dy dx, it will be dy dx plus 2y plus 3 equals to 4x. Another example we have for first ODE, here we have cos x, dy dx equals to sin x. Okay, remember we have three techniques that you can use to solve your first ODE. The first one is separable equation. Alright, the second one is homogeneous equation. The third one is linear equation. And we also have learned the application of the first order ODE. Alright, we have the first one for the growth population. Second one is radioactive decay. The third one cooling problem. And the last one we have mixing problem. Alright, so for the case number 1, 2 and 3, basically you will solve by using separable equation. Alright, but for the mixing, you have several cases, okay, and basically most of the case you will solve by using linear equation. But if you have your brine solution B is equals to 0, alright, then you have to solve by using separable equation. Alright, so next, for today we will continue with the second ODE. Alright, for the second ODE, we have here, the first example we have y double prime plus 2y prime plus y equals to 0. As you can see here, the highest order must be y double prime. Okay, second order of the derivative equation, y double prime plus 2y prime plus y equals to 0. Okay, second example, let's see here, we have y double prime plus 2y prime plus y equals to 3x. So the highest order must be y double prime. The third example, we have d2y over dx2 plus 3dy dx equals to cos x. So for the example number 3, you also have the highest order of your derivative equation is second order. And basically to solve the second order, we will write in the form of y double prime. Okay. Alright, so this is the difference between the first ODE and second ODE. You have to make sure that you can identify whether the equation given to you is the first order differential equation or the second order differential equation based on the highest order derivative that you have in that equation. Alright. Okay, so for second order, if you can see here, okay, the first example, your right hand side equals to 0. If your right hand side equals to 0, then we call it as homogeneous second order ODE. Homogeneous second order ODE. Alright, if your right hand side here, right, if your right hand side not equals to 0, then we call it as non-homogeneous second order ODE. Alright, okay, alright, so later on we will see the example or the form of your homogeneous and non-homogeneous second order ODE. Okay, next let's see what is the second order differential equation. Alright, the general form for the second order differential equation is given as ay double prime plus by prime plus cy equals to rx. So your rx is your right hand side. Okay, as I have mentioned earlier, the highest order of your derivative equation must be second order. Okay, so we have two types of the second ODE. The first one is homogeneous second ODE and the second one is non-homogeneous second ODE. So if your Rx equals to 0, then we call it as homogeneous second ODE, and if your Rx not equals to 0, then we say that it is non-homogeneous second ODE. So this is the form of homogeneous second ODE ay double prime plus by plus cy equals to 0. And for non-homogeneous second ODE, ay double prime plus by prime plus cy equals to rx. So rx can be any types of function. Okay, it can be a constant, or it can be a quadratic, a cubic function, or maybe a trigonometric function. So it depends on the question. Alright, so let's see the homogeneous second ODE. Alright. Okay, we have 3 steps to solve the homogeneous second ODE. The first step is you will write the characteristic equation. Okay, what is the characteristic equation? The characteristic equation is also known as auxiliary equation. Alright, so the characteristic equation will be in the form of a quadratic equation. Alright, how to write the characteristic equation? If you have your general form of homogeneous second ODE is ay double prime plus by prime plus cy equals to 0. Then your derivative equation, okay, will be write as a quadratic equation. So in this case, if you have your y double prime, okay, your y double prime will be write as m square. Meaning here, the order of your derivative will be represented as the power. So if you have a double prime, it will be square. If you have 1 prime, it will be power of 1, m power of 1. Okay, if you have no order of derivative here, so cy, then it will be just c. So it should be here is m power 0 is 1. So that's why we just put c. Alright, so next step, second step, you will solve the quadratic equation. So you can solve either using factorization, so just factorize as usual using your calculator, or you have to use formula of a quadratic equation. So the formula given here is m equals to negative b plus minus square root b square minus 4ac over 2a. Or for some calculator, you can just get the value by using calculator. Okay, so next step is you will obtain the solution. So the solution for the homogeneous second ODE, we will call it as the general solution, or it is also known as the complementary solution. Complementary solution. Basically, you will write as YG, okay, or some books it will be written as YC. Okay, we have 3 types of general solution or complementary solution, which depends on the roots that you have from your second step here. Okay, the first types of solution, if you have your roots is m1 and m2, you have 2 roots. Okay, the solution will be y equals to c1e m1x plus c2e power of m2x. If you have the roots is m, which means you have 2 equal roots, m1 equals to m2. Okay, then your solution will be y equals to c1e mx plus c2x e mx. Okay, so the difference between the first one is you have x here. Okay, and the power will be just m because you have m1 equals to m2. Alright, okay, maybe I just put the color is this one, m. Okay, next for the complex, okay, the third one we have complex roots. So later on we will see what is the complex roots. It is in the form of alpha plus minus beta I, this one. And the solution will be y equals to e alpha x times c1 cos beta x plus c2 sin beta x. So for these three solution you need to remember. Okay, so the first example we have here, solve the following second order differential equation. So A, we have y double prime plus 5y prime plus 6y equals to 0. Okay, so the first step that you will do is starts with your characteristic equation. Okay, so firstly, your characteristic equation will be m square, right? So this one you have, so y double prime will be m square, okay, plus 5y prime will be plus 5m, okay, and plus 6 equals to 0. Okay, next step is you will solve your quadratic equation by using factorization. That is, you can use your calculator. So when you use calculator, you will have your m plus 2 times m plus 3 equals to 0, and your m1 will be negative 2 and your m2 will be negative 3. So it's up to you whether you want to write your m1 as negative 3 or your m1 as negative 2, then there is no problem. Alright, so in here we have, okay, so we have real and two real and distinct roots. So we have two distinct roots. Alright, so for the distinct roots, what will be the general solution for your distinct roots? Okay, that's why you need to remember. If you have two distinct roots, this general solution, your YC, it will be C1e m1x plus C2e m2x, right? Okay, so the solution will be Y is C1 e negative 2x plus C2e negative 3x. So that is your answer. So this is your answer. Alright. So next, let's look at second examples. So for second examples, we have y double prime minus 12y prime plus 36y equals to 0. You have to start with the first step is characteristic equation. The characteristic equation will be m squared minus 12m plus 36 equals to 0. And when you factorize, you will get m minus x times m minus x. That is, you will have two equal roots, which is m equals to 6. Then, so your general solution y will be y equals to c1e6x plus c2xe6x. Okay, that is, you will compare with your general solution. It should be y is c1emx plus c2xemx. Then you will get this one. Okay. So we have C is y double prime minus 4y prime plus 13y equals to 0. You will start with the characteristic equation. Your characteristic equation will be m squared minus 4m plus 13 equals to 0. Okay, so if you try using calculator, for calculator FX570, okay, for that calculator you will get another answer. You cannot get the answer. Okay, but for some calculator, okay, you can get the answer in the form of complex roots. So in this case, you need to use formula. Okay, the formula is m is negative b plus minus square root of b square minus 4ac over 2a. Okay, substitute the value. Okay, we have here is, alright, so this is your a. Okay, this one will be your a equals to 1. Okay, so this one will be your b equals to negative 4, and your c will be equals to 13. Okay, alright, then continue. Okay, solve, simplify and solve. You will get 4 plus minus square root negative 36 over 2. Okay, remember, in the calculator we cannot calculate square root of negative 6. Okay, so square root of negative 6 will be no answer, so it will be math error. Okay, so in this case, we have here I is equals to square root of negative 1. So that I, we call it as imaginary number. Okay, so when you have negative square root at 36, okay, so next when you have negative square root 36, it will be negative square root 36 equals to negative square root of, okay, 36 times negative 1. Okay, then it will be square root of 36 square root of negative 1 will be equals to 6i. Okay, so next simplify, and you will get it is 4 plus minus 6i divided by 2. Okay, make sure you have to write in the form of e plus minus beta I. Okay, alpha plus minus beta I, meaning you have to separate your alpha and your beta. So you will get 2 plus minus 3i in the form of alpha plus minus beta I, which means your alpha will be equals to 2, okay, and your beta will be equals to 3. Alright, so your general solution will be, so the general solution y equals to e alpha x c1 cos beta x plus c2 sin beta x. Okay, then you just substitute your alpha and your beta. So finally your solution will be y is e2x times c1 cos 3x plus c2 sin 3x. Okay, for next example, we will see how to solve the homogeneous second order ODE if you are given the initial condition. So this is the initial condition. Okay. Alright. So we have here is your x will be 0 and your y will be 5 and your y prime will be 1. Alright. Okay, so the first step is you will write the characteristic equation. Okay, your characteristic equation will be 8m square minus 2m minus m minus 1 equals to 0, and when you solve you will get your m1 will be 1 over 2 and your m2 will be negative 1 over 4. Alright, continue. So your general solution will be y equals to c1e m1x plus c2e m2x, because you have two distinct roots. Alright. Okay, now your y will be c1e 1 over 2x plus c2e negative 1 over 4x. Next step is you have to find y prime. That is, you will differentiate your y. Okay, so this one you need to find y prime. Okay, so by differentiating your y. Okay, next steps, by using the first condition. So this is your first condition. When x equals to 0, your y will be equals to 5. Okay, substitute in your y. Okay, you will get c1e0 plus c2e0 equals to 5, and you will get c1 plus c2 equals to 5. Okay, next, use the second condition. So the second condition given is when x equals to 0, your y prime equals to 5. Equals to 1. Okay, so substitute, you will get 1 over 2 c1e0 minus 1 over 4 c2e0 equals to 1. Then simplify, you will get another equation, that is 1 over 2 c1 minus 1 over 2 1 over 4 c2 equals to 1. Okay, so now you need to simplify a simultaneous equation. So you have there, okay, c1 you can write as 5 minus c2, and that is the third equation, and we have fourth equation is 1 over 2 c1 minus 1 over 4 c2 equals to 1. Okay, then substitute the third equation into fourth equation. So you have to solve the simultaneous equation to find the value of your c1 and c2. So when you substitute and solve, you will get the answer of your c2 will be equals to 2. Okay, and you will get your c1 will be equals to 5 minus 2 equals to 3. Then now you will get your particular solution will be y is 3e 1 over 2x plus 2e negative 1 over 4x. Okay. Alright, so make sure your particular solution must be y. Okay, this one, y. Alright.